Hey everyone! Today we're jumping into the digital kitchen to break down a recipe that's totally reshaping our world, blockchain. Now I know, it can sound super complex, right? But trust me, by the end of this, you're going to see it's really just made from a few core ingredients that, when you put them together, create something incredible. Real digital trust.
So here's our game plan. First up, we'll tackle the big why. What even is digital trust, and why is it a problem? Then we'll get into the fun stuff, the actual building blocks of blockchain. After that, we'll figure out how a whole network with no one in charge can possibly agree on anything. We'll also look at how this tech is way more than just money. And finally, we'll get real about the big challenges blockchain is facing right now.
All right, so let's start at the beginning. Why was blockchain even created? Well, it all boils down to this one huge question. In a world that's completely digital, how do we trust each other? How do we exchange things of value without needing a big, central authority like a bank or a government sitting in the middle of every single transaction?
And this quote from the mysterious creator of Bitcoin, Satoshi Nakamoto, just nails it. The original goal was so simple, yet so radical. Create a form of digital money that you could send directly from one person to another, peer-to-peer. The idea was to make sending digital cash as easy as handing a friend a $5 bill. No bank, no fees, no waiting.
But here's the catch, the massive roadblock. It's called the double spending problem. Think about it. With a physical dollar, once you give it to someone, it's theirs. You don't have it anymore. You can't spend it again. But anything digital, a file, a photo, an MP3, can be copied a million times. So what's to stop someone from just copy-pasting their digital dollar and spending it over and over? For decades, the only answer was a bank, which kept the one true, official ledger.
So how in the world does blockchain get around this? It all starts with our very first ingredient, creating a totally unforgeable ledger. The goal here is to build a new kind of record book, one that everyone shares, but more importantly, one that is virtually impossible to tamper with.
The magic really begins with something called a cryptographic hash. It's an algorithm where you can put any data in, a transaction, a document, literally anything, and it spits out this unique string of numbers and letters. The best way to think of it is like a digital fingerprint. The data is the person, and the hash is their unique, one-of-a-kind fingerprint.
And these fingerprints are unbelievably sensitive. Just look at this. The input muli with a lowercase m gives you one hash, but change just that one tiny letter to an uppercase M and bam, you get a completely different unrecognizable hash. This is called the avalanche effect, and it's what makes this system so secure. If anyone tries to change even a comma in a transaction, the fingerprint changes completely, and the fraud is immediately obvious to everyone.
So what do we do with all these fingerprints? Well, a bunch of transactions get bundled together into what we call a block. Once that block is full, a hash, a fingerprint, is created for that entire block of transactions. And here's the truly genius part. That block's fingerprint is then included in the next block. This creates a chain, where every single block is cryptographically locked to the one before it. If you try to change an old block, its fingerprint changes, which breaks the fingerprint in the next block, and the next, and so on. The entire chain falls apart.
Okay, the last piece of this puzzle is your digital identity, and this is handled by a pair of keys. You have a public key, which works kind of like your bank account number. It's what you give people so they can send you stuff. Then you have your private key. This is your secret. It's like your PIN, and you never ever share it. It's what you use to create a digital signature, proving that you and only you authorized a transaction from your account.
Okay, so we've got this amazing tamper-proof chain of blocks. But wait a minute. If there are thousands of computers all over the world, and they all have a copy of this ledger, and nobody is in charge, how do they all agree on what's true? How does a network with no boss reach a consensus?
This is where a process called mining, or more formally, proof of work, comes in. All these computers on the network, who we call miners, grab a bunch of new transactions to form a block. Then they all start competing in this massive global race to solve a really hard math puzzle. They're basically trying to guess a random number that, when you add it to the block's data, produces a very specific kind of fingerprint, or hash. It's incredibly difficult and requires a ton of computing power, but here's the key. It's super easy for everyone else on the network to check the answer. The first miner to find it wins. And you might be asking, why would anyone bother doing this? Why dedicate all that electricity and processing power? Well, incentives. The winner of that race, the first miner to solve the puzzle, gets a reward. They get brand new cryptocurrency, like Bitcoin, created out of thin air, plus all the transaction fees from the block they just added. It's this brilliant system that pays people to play by the rules and use their power to secure the network for everyone.
So, there you have it. We've got our complete recipe for a secure, decentralized digital ledger. And while this was all originally designed for peer-to-peer cash, it turns out this foundational technology can be used to build so much more.
And it's really important to know that this recipe comes in different flavors. It's not one size fits all. You have public blockchains like Bitcoin or Ethereum, where literally anyone can join and participate. But you also have private or consortium blockchains, which are huge for businesses. In these systems, access is restricted. Only known pre-approved participants can join, which is obviously critical if you're dealing with sensitive corporate data.
And this flexibility just blows the doors wide open for new uses. I mean, think about it. You can have a supply chain where you can track an item from the factory to your front door on a ledger that no one can fake. Or managing our healthcare records securely, where we, the patients, actually control our own data. Then there are smart contracts that automatically pay out when certain conditions are met. No lawyers needed. The list just goes on and on.
But before we get too excited, it's time for a little dose of reality. As revolutionary as this all sounds, blockchain is not some magic wand. It comes with its own very real, very significant challenges that we absolutely have to talk about. One of the absolute biggest hurdles is speed, or what we call scalability. Let's take Bitcoin. At its peak, the network can process maybe 7 transactions per second. 7. Now compare that to something like Visa, which handles thousands every single second. That's not just a small difference, it's a massive digital traffic jam that's holding back widespread adoption.
And it's not just about speed. That whole proof-of-work mining process, it uses a staggering amount of energy. Plus, while the data on the blockchain can't be changed, it's only as reliable as the data that was put on it in the first place. You know the old saying, garbage in, garbage out. And even though the chain itself is secure, people are not. Users are still vulnerable to things like phishing scams that trick them into giving away those all-important private keys.
So after all that, what's the big takeaway? Well, blockchain is definitely not some flawless, perfect technology that's going to fix everything tomorrow. It's probably better to think of it as a powerful, foundational tool, a lot like the internet was back in the early 90s. We've got the basic recipe down, but we are all still just learning how to cook with it, how to improve it, and how to unlock its true potential. Thanks for joining me.